Let's move on now to our last method for solving systems of equations. It's going to be another algebraic method called elimination, which in this case, we're simply going to add either our equations together or a multiple of our equations together in order to eliminate one of our variables and isolate the other one. So nice and easy. In this first example, we can see that we have these two y terms with opposite valued coefficients here. So if we were to add these two equations together, we could see that we get 2x plus 3x gives us a total of 5x. Positive y minus y gives us a total of 0y. And 9 plus 16 gives me 25. So now we have 5x is equal to 25, which dividing both sides by 5 gives me x is equal to 5. Then we can just plug this answer back into either one of our two equations to solve for y here. So we have 10 plus y is equal to 9 minus 10 on both sides, and we'll get y is equal to -1. So this will give me the final answer of 5, -1. Now again, try out this next problem on your own and go ahead and see if you can use elimination this time to see if you can eliminate one of these two variables. I will say this one is a little more tricky, so to give you a helpful hint, you're going to need to multiply both of these two equations by some scalar factor in order to eliminate one of our two variables. So go ahead and pause that now and see if you can figure out how to solve this system. Okay, so in this case, we can see that none of our terms will easily eliminate with one another, but we can multiply each of our two equations by a scalar value in order to make our elimination a little easier. So for this first one, I'm just going to multiply by the opposite of, or the opposite's equation lead coefficient of 3. And then the second one, I'm going to do the same thing where I'm multiplying by 4. This will give me a 12 and a -12 for our two lead terms here and allow us to cancel out those x's. So I'm going to recopy down my two equations here. That's 12x minus 9y is equal to 75. Then on our second equation, we'll get -12x plus 32y is equal to 40. And then we're going to want to add these two together. So our two x terms will cancel out. And then we'll have 32 minus 9y gets me 23y. Then we have 75 plus 40 gives us 115, which if we divide by 23 on both sides, we should get y is equal to 5. Now we can plug back in our 5 to either one of our first two equations to allow us to solve for x. So I'll just take our first equation of 4x minus 3 times 5 is equal to 25. So 4x minus 15 is equal to 25, which will give us 4x is equal to 40, or x is equal to 10. So in this case, we've got the solution of 10, 5. Okay, we've got two more problems to wrap up today's lesson. First up, we've got at a candy store, Jane buys 5 packs of gum and 4 bars of chocolate for $8.50. The total cost of 1 pack of gum and 1 chocolate bar is $2. How much does 1 chocolate bar cost? So we're going to need to set up a system here. And I'm going to use C to represent our chocolate. And let's use G for our gum. This will just help us keep our variables a little more consistent throughout our solution here. So now let's take the information that we do know and set up some equations. We're told with 5 packs of gum and the addition of 4 packs of chocolate, that total is $8.50, which I'm just going to write as 8.5. Then we're also told if we buy just one of each, we're spending $2. So we get this system of two equations, which I think the easiest method to solve this is just going to be substitution here. So I'm going to solve for my G term, in this second equation and get g is equal to negative c plus 2. Now let's rewrite my first equation by substituting in negative c plus 2 for g. And that is still set all equal to 8.5. So now we're going to get negative 5c plus 10 plus 4c is all equal to 8.5. Then combining our like terms for c, we should just get negative 1c plus 10 is equal to 8.5. Subtracting 10, we'll get negative c is equal to negative 1.5, or c is equal to 1.5, which should make sense that we're getting a positive number here. And we can actually stop there because we solved for the one variable we were interested in, our chocolate bar. So we're saying each chocolate bar individually costs $1.50, our 1.5 here. Then for our last problem, we have a system of equations as shown. 3k plus p is equal to 2, and negative 3k plus 3p is equal to 17. What is the value of k? So I think for this last one, why don't you go ahead and work through this one on your own, and then once you're ready, you can go ahead and go over the solutions together with me, but pause and work through this one either using substitution or elimination. So try that out for a moment now. Alright, so in this one, I'm not sure what your thoughts were, but I immediately saw our positive and negative 3's for our k terms and thought those would be very nice to eliminate with one another, making for our solution pretty quick to solve. So 3k and negative 3k, they cancel out. P plus 3p gives me 4p. And then adding my 2 to my 17 here gets me 19. So if we divide by 4 on both sides, we'll get p is equal to 19 over 4. Then if I want to solve for the value of k, I'm just going to plug in my p for one of my equations, which I'm going to pick the first one just because that's really easy here where I don't have anything to multiply by my 19/4. Subtracting 19 over 4 on both sides, we'll get 3k is equal to negative 7, or negative 11 over 4. Now if I want to solve for k, I can divide by 3 on both sides, or write it as multiplying by 1/3. Sometimes that's a little easier when we have multiple fractions going on, which is going to give us k is equal to negative 11 over 12. That'll wrap it up for today's lesson. I hope you've all been doing well. Take care, everyone.